Let's review the topics on homework number 18. The first topic is reflecting points over an axis. When reflecting a point over an axis, the rules are always that you change one coordinate sign. So if you are reflecting over the x-axis, then you are going to change the sign of the y-coordinate. That doesn't mean make it negative, that means make it opposite. So if you are going over the x-axis, you are changing the sign of the y-coordinate. If you are going over the y-axis, then you are changing the sign of the x-coordinate. So for this problem here, the first set of directions are that you are going to reflect point M over the x-axis. So point M is going to be reflected over the x-axis. So the original M, which is -2, -4, will become a new point called M prime. And when you reflect over the x-axis, you change the sign of the y. So M prime will be -2, +4. They then want you to take this point, M prime, and reflect it over the y-axis. So this will become M double prime. When you reflect over the y-axis, you change the sign of the x-coordinate. This is the point they want you to type here. And submit. Let's try this one more time. Point F is 4, 6. We want to take point F and reflect it over the x-axis. This will be point F prime. When you reflect over x, you change the y. Now I want to take this point and reflect it over the y-axis to become F double prime. When you reflect over y, you change the x. So our new coordinate will be -4, -6. All right, let's take a look at the next topic, which is identifying a single rotation or a single reflection. So for a reflection, you're either going to be flipping over the y-axis or you're going to be flipping over the x-axis. So for us, when I concentrate on this point here, I can see that it's on the same line, but on the other side of the y-axis. So this is definitely a reflection. And I know that it has reflected from left to right over the y-axis. So we're going to choose reflection over the y-axis. Reflection over the y-axis. Let's take a look at another one. This time I can see that it is not reflecting over y, which would place it here. It is not reflecting over x, which would place it there. So it has definitely made two turns. That is a 180-degree turn. A reflection would move you one quadrant. This one moved 2 quadrants, so it is a clockwise or counterclockwise, doesn't matter, but it must be 180 degrees. 2 turns. All right, let's take a look. This did not, shape A is our starting shape, this did not reflect over the y-axis. It would place it over there. This is facing the opposite direction, so that is a reflection over the x-axis. Reflection over the x-axis. If you're unsure, you can always choose a point that you know matches from the original shape to the new shape. So let's see, I'm going to take this point here. And I can see that that point has coordinates of 7, 8. And I know because it's like this little area here. I know that it matches this little area here. So its new point would be this one. And when I look at those coordinates, so I'll call that point, original point A. And it looks like A prime is located at -8, +7. You notice how these two values swapped places? Well, that only happens when you turn 90 degrees. That only happens when you rotate 90 degrees. Now you can rotate clockwise or you can rotate counterclockwise. So I could call this a 90 degrees counterclockwise rotation, or I could say that I rotated 1, 2, 3 times 90 degrees, which is where 270 might come from. So let's look at our options. A counterclockwise rotation of 90, a clockwise rotation of 270 degrees. So a counterclockwise is left. That's left one turn. A counterclockwise 270 would be 90, 180, 270. And we can see that the shape is not down here. So this is a counterclockwise rotation of 90 degrees. Again, if you're not sure, you can always check the coordinate points. Right? So if I choose, let's see, this little weird area, right? You see this area? It seems a little bit different than the rest of the shape. So I'm going to concentrate on this little point, which maps to that little point. The original point, I'll call it A, is -2, -8. The new point, I'll call it A prime, looks like -8, +2. Do you notice the swapping? That only happens with a 90 or 270 degree turn. It looks like I rotated one quadrant, but the arrows are going in this direction like the clock. So this is a 90 degree clockwise, or I could say 90 degrees, 270 degrees counterclockwise. So my options are 90 degrees clockwise or 270 degrees counterclockwise. Those are my options. So let's take a look. Our options are, we want a rotation, so that's out. We want a rotation, so that's out. So it's either counterclockwise 270, so starting from here, counterclockwise 270, yep, or counterclockwise 90. Counterclockwise 90 would be like this. So we have found our solution. It is counterclockwise 270. All right, let's take a look at the third topic, identifying any type of transformation. All right, the most important part of this lesson is figuring out which one is the old shape and which one is the new shape, so that you can identify the right direction. Figure M is the result, so that means this is the new shape. It's a result of the old shape moving. So we have our new shape here, our old shape is blue. So the question is, how does the blue get to the green? I'm going to look at some points here. I'll call this point A, it's -4, 0. And I'll call this new point A prime, and that is the point -3, 4. All right, these numbers are completely different. So that means a translation has to occur. The only way for the numbers to be different digits is for a translation to occur. So let's take a look. 1, 2, 3, 4 units up, 1 unit right. 4 units up, 1 unit right. Well, up affects the y, right affects the x. So let's see, we've got 4 units left, 1 unit down. Reflection, 1 unit right, 4 units up. There it is. So we have found it. And I know that that's right because the digits in the coordinates are completely different. Aren't translations. Look at this one. Figure R is the result. So this is the new shape. So let's see here. If I folded it along this line, would this be 1 up, 1 down? Yep. 2 up, 2 down? Yep. 5 down, 5 up? Yes. This is a reflection over the x-axis. Let's take a look here. Looks like we have the new shape over here and the old shape over there. So, is this 2 units in and this is 2 units in? 1 unit, 1 unit, 2 units, 2 units. That is definitely a reflection over the y-axis. Okay, let's go back and take a look at compositions of transformations. In this topic, they want you to identify the transformation and then the second transformation. So let's see. Determine a series of transformations that would take M onto N. So this is the new figure. N for new. So we need to get the blue to the green. And I definitely see that this green shape is upside down. So that is definitely a reflection happened. And it happened over the x-axis. So let's see that happen. Alright, if that comes down, right, so I try that. Okay. Once I click try, it really helps me to visualize what happens next. It looks like it slides over 3 units to the right. Slides over 3 units to the right. Let's try it. Reflect over, and then 3 units to the right. Fantastic. Now we can submit it. All right, this allows you to try the transformation first to see if you get in the right area. This definitely looks like it's turning here. But I think it's only a quarter turn. Remember, you have to make 2 moves. So I'm going to rotate this 1 time, and I'm going to rotate it to the right or clockwise. I'm going to try it first and then see, perfect. Now I know if I fold it along this x-axis or reflect it over the x-axis, I'm going to get a perfect overlap. So rotate and reflect. Fantastic. All right. Good luck trying those transformations. Let's take a look at scaling or dilating figures. So please make sure you know which one is the new and which one is the old shape. So the figure on the right is the new shape. So anytime you figure out a dilation factor, you need the new number of the length over the old number of the length. So first we need to find a congruent side, right? 2 sides that map to each other. So let's take a look. They want us to map WV. So WV is this short side here, and it would map to DE or ED. Either way, it doesn't matter which way you name it. So we're going to choose that from the drop-down menu. And now we're going to compare the new length with the old length. So the new length is 3 boxes. The old length was 2 boxes. So that means the dilation factor is 3/2. So we're going to select that from the drop-down menu. Remember, new over old. New length over old length. So you got to make sure you know which one is the new one. Figure on the right is the new one. And first, we're going to find out which side they're talking about. So they have GE, that's G to E. That would be N to L. That would be N to L. And now I can't measure a crooked line. So I'm going to choose any different line, these here, because these go along a grid box. That can be counted. So the new length was 1, the old length was 3. Now you can only count a straight or up and down or a straight left and right line. So my dilation factor is 1/3. From the drop-down menu and submit. Remember, new length over old length. New length over old length. All right, let's just dilate a point using math now. So my original point is 8, 8. I'm going to multiply that by 1/4. When you multiply a whole number by a fraction, that means you multiply the numerator and then you multiply the denominators if there are 2 of them. In this case there isn't, so I simply reduce it. Because these are both 8s, they'll both have the same solution, which is 2, 2. We'll type that here in the answer key and submit. Let's do this again. All right, last one. 9 and 8 by a scale factor of 5. You simply multiply both numbers by the scale factor. 9 times 5 is 45. 8 times 5 is 40. All right, let's determine if a set of points is a function. When you have ordered pairs, a function has no repeating x's. So this one says which one is not a function. So we want something that does have repeating x's. Repeating x's. So let's take a look here. 8, 6, 4, 0, that is a function. 8, 1, negative 7, 9, that is a function. 4, negative 3, 7, negative 6, no repeats, that is a function. And this right here is the winner. We have repeating negative 9s, and that means it's not a function. Again, you are looking for repeating x's. This one says which one is a function. Which one has no repeating x values with different y values. So let's see. There's a repeat, so that's out. There's a repeat, so that's out. There's a repeat, so that's out. These are all unique. So this is our function. Last two topics. This one is determine if a graph is a function. Again, we're looking for repeating x's, and we do that by using a vertical line test. If at any time you touch the vertical line in more than one location, then you have repeating x values with different y values. This fails the vertical line test. It's not a function. This fails the vertical line test. This is not a function. This one passes the vertical line test. This one is our first function. As you can see, as it scans from left to right, see how it's scanning left to right? It never touches more than one time. Okay, last topic, writing equations of lines. Equations of lines have the format y equals mx plus b. This number is the y-intercept. This number is the slope, or the change in the y location over the change in the x location, often known as the rise over the run. So first I'm going to start with the y-intercept. So y equals mx plus b. My y-intercept is negative 8, so that means I need to put a negative 8 here. And now I'm going to count the slope between any 2 points I like. Any 2 points I like. So let me zoom in here so you can see as I count. I'll count between these 2 points. So my rise is 1. My rise is 1, 2, 3, 4, 5. My run is 1. 5 over 1. So again, my equation will be 5 over 1, or just 5, with the x, and then negative 8 for the y-intercept. Let's try that one more time. The y-intercept is 6. The rise is 2. The run is 1, 2, 3, 4, 5. So that's 2 over 5x plus 6 with a y equals sign in front. 2/5 x plus 6. And that concludes homework number 18.